So this is Forces Quiz 3 Answers. It's due today. Mark your own. Here we go. Oh, got to have my favorite student, good old Anne. I like number one. Number one, isn't it? You know what? Except for the very last question, every one of these questions is going to show up in some variety on your test with different numbers. I'll even be that blatant. Okay? So no surprises, especially on the written section. Given the following massless, frictionless okay. A couple of things I noticed. Haley, how big is mass 1? How big is mass 2? I noticed they're almost the same. Not quite. If the masses were identical, what would the acceleration be? Taylor? Are the masses nearly identical? I'm just guessing. You guys got a pretty small acceleration, I'm guessing. In fact, I won't be shocked if it's less than 1 meter per second squared. In other words, if I do get that, I won't freak out. I'll say, actually, it's nearly balanced. Not quite, nearly. Haley, how big was mass 1? That's about 50 pounds. How big is mass 2? Also about 50 pounds. You know what? There's about 100 pounds hanging on this rope. This is a guess, again. Did you get a fairly big answer for tension? I'm going to guess it's over 100 newtons, just off the top of my head, but probably, yeah? So I have a bit of a gut instinct of where I'm heading for this question. I like to have an idea of whether really, Linnea, I like to be able to spot a calculator mistake because that answer doesn't look right at all. I can go back and figure that out. Let's do our free body diagram. Technically, this is not a free body diagram. We're labeling the forces. Technically, the free body diagram would be rewriting everything with a dot. Oh, wait a minute. Tension is smaller, so I shouldn't draw that way. M2G tension. Who's winning? M1G minus tension plus tension minus M2G. I know M1 is winning because it's the bigger mass. Equals M1 plus M2 times A. Oh, I relax. Nice. I want to get the A by itself. I think I would divide the bracket over. The M1G would drop down like a domino. The minus M2G would drop down like a domino. And I would have M1 plus M2, and that is A equals. M1, 21.3, 19 point, 21.3 times 9.8 minus 19.6 times 9.8, all divided by 21.3 plus 19.6. Bracket 21.3 times 9.8 minus 19.6 times 9.8 divided by bracket 21.3 plus 19.6. Double check my typing. Looks good. Do you get 0.407, 0.41? Yeah? I'll go to 3. I guess I went to 3 sig figs with my masses, so I'll go to 3 sig figs. 407 meters per second squared. If you got that, 4 out of 4. Mr. Dewick, why did you make this worth 4 marks? Because I can't help noticing that you wrote 1, 2, 3, 4 lines worth of work. I could have made it worth 2 marks and given you a half mark for each line as well, but there you go. But again, if you get the right answer, full marks. Find the tension in the cord. I'm going to find the tension using mass 2 because in that one, tension is a winner. You could find the tension using mass 1, and Darcy, you'll get the same answer as us. You'll just have to do one extra line of work, and I'm lazy in a good way. Who's winning? Tension. Who's losing? M2G. That equals M2A. Because this is way easier to get the tension by itself. It's going to be M2A plus M2G. M2 was 19.6. I'm going to write, Patrick, 0.407, but you know I'm going to use my answer button here, right? Plus 19.6 times 9.8. This is probably going to be over 200, I think, not just over 100. because it's roughly 20 times 10, that second number there. 19.6 times answer button plus 19.6 times 9.8. Oh, yeah, there you go. I'll call it 200 even, 200.1, I take that. But I'll go to 3 sig figs, so I'll go 200 point. And that's a force newtons. 1 mark, 1 mark, half mark, half mark. But if you got the right answer, 3 out of 3. I like question 2. I like question on your test. Now, the only thing I don't like about question 2 on this quiz, and I'm going to change it next year, I didn't give you enough room to write easily. I should have given you a little less room for the Atwood machine, a little more room for number 2. On your test, I guarantee, Jenna, there's going to be a question that has an extra vertical force besides gravity and normal force. In this case, the 19 pointing up, I could give you a different force pointing down. It's really the same question. Jenna, what does question 2 want me to find? Is there more than one force in this question? This is a job for a free body diagram. Although rather than do a separate diagram, if it's okay with you, I'm just going to label the forces on my diagram. So what are the forces acting on this mass? Get the obvious one, mg. There is a normal force, but the normal force is going to be smaller. Why? Because that 19 newtons is canceling out some of how big the normal force has to be. There's the applied force. There's friction. Hey folks, who's winning? Good. Who's losing? Good. What's that going to equal? Because there's only one mass. What are they asking me to find? How to get the A by itself. Yeah. So I think I'm going to get this. A equals F applied minus friction is why I think I didn't leave you much room, divided by M. All right. Well, the applied force is 12. Friction is mu times the normal force divided by M. Do I know mu? 0.48. I don't know the normal force. And I can't quite say, oh, but look, I know another force the same size as the normal force, because there's other vertical forces. The normal force here is not mg. Here's what I can say. Are you ready, Darcy? Is it sinking into the ground like quicksand? Is it flying to you like Superman? What that really means is vertically all my forces are balanced, or everything pointing up has to equal everything pointing. As an equation, everything pointing up has to equal everything pointing down. What's pointing down? Yeah. I want to find the normal force. Folks, how would I get the normal force by itself? Minus 19. Yep. This is why I've told you I will never give you an actual equation on your formula sheet to find the normal force. What I've said, Daniela, is, from a good free body diagram, you can figure it out. It's going to be mg minus 19. M is 3.6. I'm going to crunch that right now. 3.6 times 9.8 minus 19. And I'm not going to round this off because I'm going to be using this to find other answers. I'm going to use 16.28 newtons. And that is going to go down here. It's going to be 12 minus, coming back to you now, Patrick. Hey, what's mu? I don't know. What's mu with you? What's mu? 0.48. Times the normal force, which in this case is 16.28 divided by M, 3.6. Cool. I don't know what the answer is going to be here. 12 minus 0.48 times, I don't need to multiply by mass. I'm multiplying by the normal force, so I'm just going to use the 16.28 divided by 3.6. Do you get 1.162? I'll call it 1.16? 1.2? Is that right, folks? Yeah? I'll go 1.16 meters per second squared. Now, if you got that, you get 3 out of 3. Otherwise, I would give you 1, 2, 3, 4, 5, sure. Half mark for that, half mark for that, half mark for that line, half mark for that line, a half mark for successfully finding the normal force, and a half mark for the answer. The most common mistake on these, Luke, is kids just say the normal force is mg. If you did that, you would get this, 12 minus mg divided by that. You would get a negative acceleration. Oh, I forgot mu, Mr. Duick. 12 minus mu times the normal force. Nice try. 0.48 times. You'd get a negative acceleration, which suggests to you you've got the wrong winner or something's wonky. But I have kids do this, and then in desperation, they just magically throw away the negative and they say, the acceleration is 1.37. In fact, I bet someone in this class did that. I would cap that at the best you can do is 1.5 out of 3. I'd give you a pass on the question, but I'd say you're missing some fundamental concepts. So if you wrote that. If you do ever get a negative acceleration, it usually means you picked the wrong winner. Start over and redo your free body diagram, and your arrows should be probably pointing in the, well, you picked the wrong winner. So who's winning? Start there. It also might mean that you have friction pointing the wrong way. We'll look at that more in Physics 12. Number 3. Lyndon, who's winning? There is no friction. That's why it says assume there is no friction. Nice try. Huh? F1. Who's losing? So I think you're saying, Mr. Duick, really? And it wants me to find A, how to get the A by itself. So 60 minus 36 divided by 12. Oh, I can do that in my head. It's 24 divided by 12. In your head, Lyndon, what's 24 divided by 12? A, B, C, or D? B. Okay. There, I kind of did the free body diagram for you. It is true, Darcy, that there's gravity down and normal force up, but I clued in they canceled and weren't affecting the question at all, especially if there's no friction. Number 4, I asked you to draw the free body diagram, and I want you to draw the free body diagram here. I will also let you label this, but whatever you put here, I'm not going to mark. The free body diagram, we represent the mass with a dot. What are the forces acting on this box? Get the obvious one, everybody. Don't all shout it out at once. Is this box sinking to the ground like quicksand? No. Is it flying you like Superman? No. Are there any other vertical forces kicking around this picture? Here I can say normal force is the same length as gravity, and I would look for that. If your two arrows aren't roughly the same length, I'm taking marks off, and I'll tell you how in a second. What else? Pointing which way? Okay. What else?
Friction.
Friction pointing which way? Bigger, smaller, or the same size as if applied? Smaller. That's what I would look for. How many arrows did I draw? 4. How many marks is this worth? 2. What would be a clever marking scheme? Maybe half mark per arrow? So if you botched one of the arrow's lengths, for example, if you have friction bigger than F applied, I'm taking a half mark off. Oh, the kind of free body diagram that I would ask in Physics 12 be something like number 2, where there's extra vertical forces and where the normal force is not going to be mg, because that's such a habit kids pick up, and I want to break you of that. It's often mg, but only for boring questions. Usually the normal force is something different. It says find the acceleration. Who's winning? F applied. Who's losing? Friction. What's that equal? MA. I think then A is going to be F applied minus friction over M. It's going to be F applied minus mu times the normal force over M. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force this time because it's a nicer free body diagram. It's going to be F applied minus mu mg all over M. Here we go. It's going to be I've scrolled down. How big was F applied? Really? That's big. 225 minus, hey Taylor, what's mu? I don't know. What's mu with you? What's mu? 0.15? By the way, just as a nerd, that's about snow. You're pulling something over snow. So not quite as slippery as ice, but still pretty slick. Taylor, what was mass? G, you don't need to tell me, 9.8 divided by 100. You know, I don't think this is going to accelerate much at all. This is barely going to be moving. I'm doing some quick math in my head, and it almost balances out. Not quite. Am I right? Is it a really small acceleration? Oh, thank you, typo. By the way, I would have caught that because I would have said, what? Negative huh? And that's the beauty of the method that I'm teaching you as well, is there are many built-in error checks along the way. Then I would go hunting for my typo. Do you get 0.78? Yeah? By the way, what that really means is this person is really this barely moving, right? Barely accelerating. If you got that right, 2 out of 2. Otherwise, I would probably give you half mark for that line, half mark for that line, half mark for that line, and a half mark for the answer. Something like that. Then I would turn the page. Oh, I like number 5. Yeah, you can guarantee there's going to be 2 masses, at least one of which has some friction. Maybe both will have friction. Here, one has friction. You know what this is a job for? Hey, here we go. We're figuring this out. What are the forces acting on mass 1? Get the obvious one. M1G and normal force. I'll call it normal force number 1 to go with math number 1, just to stay organized. I think I got some tension. And there must be friction force number 1 pointing that way to go with mass number 1 and normal force number 1. And I think I have M2G tension. Mr. Dueck? Yeah? Mass 1 is bigger. It's 6.3. Doesn't that mean it's winning? The real tug of war here, Michael, is between that one and that one, because the tensions are going to cancel. In fact, if you're not sure who's winning, you can actually quickly just crunch these. M2, 4.6 times G. That's gravity down on the right-hand side. Friction is mu times the normal force. I don't know the normal force. Oh, but look. The force of friction is, I typed that wrong, Mr. Dueck. $11.7. The force of gravity is 45. Who's winning? Force of gravity. Now, if I made this mass here like 1,000 kilograms, then friction might be so big that this would just be dangling, hanging in midair, and nothing would be moving. It's possible. But I didn't do that here. Who's winning? Pretty sure it's going to be M2G, and then I have minus tension, then I have plus tension, then I have minus friction force number 1, and since I've written forces from more than one mass, I better have, in brackets, more than one mass. Hey, Sydney, relax a little. Lose some tension. Sydney, how would I get the A by itself? So this would drop down like a domino. You're telling me M1 plus M2. Like that? I think I agree. I got to do something with friction, don't I? So it's going to be M2G minus mu times the normal force, number 1, all over M1 plus M2. I don't know the normal force. Oh, but look. I know the force is the same size as the normal force. It's going to be M2G minus mu M1G all over M1 plus M2. Natasha's yawning her way through this. That's okay. At least you're awake, vaguely. Natasha, I've scrolled down. How big was M2? 4.6. G I know is 9.8 minus, hey Natasha, what's mu? I don't know, what's mu with you? What was it? Point? No, no, mu. It's in the picture somewhere, I hope. Psst. Right? Yeah, so easy that it was tough. I know. Those are out there too. 0.19, yeah? 0.19. Oh, I've scrolled down. What was M1? 6 something. 6.3, 9.8. Yoink. M1, 6.3. M2, 4.6. I have no idea what the answer is going to be here. Bracket. 4.6 times 9.8 minus 0.19 times 6.3 times 9.8, close bracket, divided by bracket, 6.3 plus 4.6, close bracket, close. Okay. Do you get 3.06? And that's going to be meters per second squared. If you got that, 4 out of 4. Otherwise, I'd probably, let's see, 1, 2, 3, 4, 5, yeah, okay. I'd probably go something like 1 mark for that, half mark for that, half mark for that, half mark for that, 1.5, 2.5, 3, 4, I don't know, something like that. Oh, find the tension. Even though tension is winning with mass 1, and you could use mass 1, I find, Connor, the whole friction thing is always a little more work. So I'm going to use mass 2 to find tension, even though technically tension's the loser. I think the equation will be cleaner to deal with, because I think I'm going to get this. M2G minus tension equals M2A. Connor, what am I trying to find? I think we'll do the little swappy dance, yes? So I'm going to get the M2G dropping down minus M2A, and that equals tension. What was M2, Connor? 4.6, is that right? Times 9.8 minus 4.6. Connor, I'm going to write 3.06, but you know I'm using my answer button because it's still stored. 4.6 times 9.8 minus 4.6 times answer button. Do y'all get for tension, oh, almost exactly 31 newtons? Almost worked out evenly? Otherwise, 4 lines of work, half mark for each. Half mark for that line, half mark for that line, half mark for that line, half mark for the answer. But if you got it right, 2 out of 2. Number 6, part B won't be on your test. Christina, what am I asking you to find in part B? I stuck it on the quiz. I'm not going to stick it on the test. Part A, finding tension. Sure. Okay. Any thoughts on what this is a job for? Free body diagram, you say. Hey, what are the forces acting on this 4.2? Get the obvious one. M1G. Normal force number 1. Tension. Oh, wait a minute. Is there friction? Nice try, Mr. Dewick. Don't get sloppy. M2G. Tension. Brian, what am I trying to find in part A? I'm going to use the mass that I know. I'm going to write an equation for mass 1. Okay. Looking at mass 1, Brian, who's winning? Who's losing? Nothing. You get tension equals M1A, which is going to be 4.2 times 3.2 13.4? 13.44. I'll write 13.4 newtons. I'll go to 3 sig figs, but I'll keep that number on my calculator. All right. Here's the little curveball. Kind of fun, though. Mobeen, what does part B want me to find? Which one? Let's write an equation for mass 2. Which way is mass 2 accelerating, Mobeen, up or down? Which one? You got one of those right. That's the good news. Down? Yeah, if this is on wheels, this is going to get pulled sideways and down. So if this is accelerating down, which force is winning? Which force is losing? So you're telling me, and I think I agree, M2G minus tension equals what? Which M? Thank you. Well, Bean, what do you say we're trying to find? M2? How many M2s do I have in my equation? How many would I prefer? One would be nicer. Hey, let's get them to the same size. Let's do a little swappy dance. We'll get M2G minus M2A equals tension. That looks a little better. How many M2s do I have? How many would I prefer? You know what would be really cool? It'd be really cool if there was a grade 9 mathematical operation that I could pull in my back pocket and somehow change this from 2 M2s into a single solitary 1 M2. Is there one? No! What? Really? I can now factor out a greatest common factor. There's an M2 and everything. And I'll get M2 bracket G minus A equals tension. Bring it home, Mobeen. How would I get the M2 by itself? What will I do with that bracket? Oh, so you're telling me M2 is going to be tension divided by G minus A. It's going to be, what was tension? 13.44 divided by 9.8 minus, was acceleration 3.2? Yes, it was. Answer button divided by bracket 9.8 minus 3.2. You get 2.04? 2.0? I'll go 2.04. Final bit, Mobeen, units for mass. Good. If you got that right, 3 out of 3. Otherwise, 1, 2, 3, 4, 5, 6. Yeah, I'd probably go half mark, half mark, half mark, half mark, half mark, half mark. With a nerdy smile of confidence, I would give myself a lovely score at the top of the page out of 27. Any lawyering with me? Now is the time. Last day, I also gave you the unit review on forces. Okay? So, for the remainder of class, if you want to, you can work on this. You can also work on any missing assignments that you have. Or if you want to, you can plan out your balloon car racer. Here's what I do not want to see. I do not want to see people looking at their smart device screen unless you're doing research for a car design, and I'll check. And I don't want to see people sleep. In other words, use this time. I'm giving you a half hour. This is your chance to either work on review or work on your cars. On Tuesday, we'll start the next unit. I'll get about halfway through the lesson. I'll also be doing a shuffle because I can't stand this front row. Oh, I'm sorry, that came out wrong.